Hello everyone, hope you're doing well. Just to recap last video, we talked a bit about the different types of variables and values in R and how R treats them. In this video, we're finally going to start learning how to manipulate and summarize data to an extent in R. I hope that this video will be formatted in a way that allows you to apply to your current situation if you're asked to work on some data. Um, and I'll try to format it in a way that matches along with the normal steps you take in a project. So let's give a hypothetical that you're um, interested in working on some data, or a researcher you're working with is working on some data, and they send it to you for you to work on and get to know a little bit. And the first thing you're gonna do is we'll open up. Actually, before we open up our studios, let's the first thing we need to do is to move the data that we have. So let's say you had data that you got from an email, and we had two different files that came in two different formats. So this format, CSV, is CSV stands for comma spaced values, I believe, and it's a very popular way of formatting data in like a data table set. And the other way is the other type of file is a XLS, which is a type of file that Excel uses. And the first thing we have to do is to move the data into whatever R project you're going to be working on it in. So to do that, we're going to just drag the files into the location or the working directory of our R project. And that makes it very easy to actually call upon and load the data into R Studios when you're working on it. And I'll show you why once I start R up. And as it starts up, I want to mention that we're going to be using a couple of functions from the dplyr package, and it's one of the packages that is included in the tidyverse package set. So all you need to do is load up the tidyverse package when you start. So because this is supposed to mimic this lesson is supposed to mimic how things would go if you were actually working on data that you're given. Let's open up a script file. And like I said before, in one of the earlier videos, a script is like it is like a Microsoft Word file where you can write things down and it'll save for later. So let's just do save because we can work on this another time. So should pop up this type of window, and let's just name it my first script. You save, and that's going to be, as you'll see here, that's going to be in the same working directory as our project. So now that we have that, like I said, the first thing we want to do when working on code is to load up all of the packages and functions that you're going to be using as you code. So the most important one for this is the tidyverse package. So you're just gonna you do that for the first line, and then you can highlight it, and then either press run, or you can just do Command Enter, and I'll send it to the console, and then the console will run that code and load up these packages. So the first thing we want to do is, now that we have the proper functions, let's get the files into R. So you're going to want to create a storage object for your data table that you're going to be creating from the files we have, and it should be a name that matches matches the type of data that you're loading up. So let's just do since the first one we're going to work on is data set on tooth growth and different type of supplements that can help tooth growth, I believe. So let's just call it tooth, and we're going to use the function read underscore CSV, because that is the type of file that we're going to be bringing into R. So we're going to do read CSV, press enter. That gets these parentheses. And then what you're going to do is you're going to put in the file path, which just means like you're specifying the folders and location within the working directory that these files exist in, so that R knows where to look for to load it up. And you're gonna put it in the parentheses. So you're gonna write the file name in parentheses. So the first thing we need to write, so we're starting in the working directory. The working directory is where the project is. So this is all the files in the working directory. However, our files aren't directly here, they're in this folder. So for the first thing we need to write is the folder name, research space data. Now, once we get into the data, so now we've covered that. Now we need to specify the file. So to separate the name of the folder and the file, we just add a backslash, and then we write the name of the file, so it's toothgrowth.csv, and now we just do enter. We run the code, and we should get a data file. A storage object that is the data frame. And as you can see here, it tells you the amount of variables, which is just the amount of columns, and then the amount of observations, which is the amount of rows. So if you click on it to see it, you'll see we have what looks like a data table. But then when you go up here, you'll notice that there's some, so that's this top row should have the names of the variables that you're working with. That's how you want it to be formatted. But you see here that there's actually a couple of rows that are meaningless and don't really add anything to the data. So this top one and this second one don't really have anything to do with data. This second row, which is length, supplement, dose, that clearly is going to be should be the names, and the top column, the top row of this data set. So the way to fix that is when you're doing this function, if you see that there's extra rows that you don't need, you simply add another argument. So you add a comma, and then you do skip, which tells R to throw out as many rows as you mentioned in this argument. So for us, we're only going to skip 2, because if we get rid of these two, this one and this one's going to be at this row. It's going to go on top, and it'll make sense. So let's run this. And once we do that, we should check. And now the column titles are properly named. So that is how you would upload a CSV into R. The other example we have here is cafe data, And I already opened it up. So what you want to do is you want to, with an Excel sheet, because it's you have like you can have different sheets in the Excel file. Like you have like uh you can add sheets to this bottom row. This file has a code book in the front that tells you like what each variable name means, um, and then the actual data itself. So, um, if you just uploaded this file into R, it would show this and not this, and it would be pretty meaningless. So, what we want to do is we want to include that in our function. However, we can't use tidyverse doesn't have an Excel read in like a function to read in. Reading in just means uploading files onto R. So uh, it doesn't have a file for that for Excel. I mean a function for that for Excel. So what you're gonna have to do is you're gonna need to download the package. Um, you're gonna need to download the package to read Excel, and the way you do that is just install dot packages, and then you do read Excel, and then you would press enter. But I'm not gonna make sure it's in parentheses, but I'm not gonna do that because I already have the function for that. I already have that package. So I can just upload it by doing library read Excel. And pay attention to um, how I'm formatting my code. Um, because when you write these scripts, you need to be able to understand what's going on when you read back through it, and you want to have good organization. So always put, whenever you're loading up packages, always put it up top, um, and then um, and then start and then add everything else below. So I'm gonna run this one, so I can have I have a function to read in that Excel file, and also just to add even more data organization and help so that we can better remember what we're working on. I'm gonna add a comment, and the way you add comments to a R file is just by doing a hashtag sign. If you do hashtag and then write something, when you run the code, like let's say you run this whole code, it won't read that as code. It will just read that as text for yourself, so that it doesn't like mess up the actual function of R. And it's just for you to read back on, so you can get a better understanding of what's going on. So let's write reading in data. So that this node is just for me, and it's just to um, orient myself. So when I go back to this file, I'll know what I'm doing past here, and then every time I change what I'm doing, I will add another comment and make that distinction. So let me do the same thing for the Excel file, but I'll do cafe, and I'll use the read underscore Excel, and then I'll do this. This will be the same, but then I need to write the file for this one, which is cafe data dot xls close parentheses, and then instead of saying skip, which would skip like rows, I'll just tell it which sheet that I want it to upload. And looking at this file, you can tell that it's the second sheet. This is the first one, this is the second. I want this one to be uploaded because that's the actual data. So this sheet equals 2, and then I'll run it. And now we have this data set. And you can see this is the actual data. So now that we have that, let's start actually going into the functions that we can use to work on the data and make it a little more organized, or isolate different variables so you could learn more about your data, not to have everything there at once. So let's go to the tooth data. Um, Actually, let's start off with the cafe data. So let's say you just wanted to look at, so this is a cafe data of sales on different sales and how much food was left over for different products like cookies, muffins, fruit cups, and it says which day it was and actual date. So let's say we were only interested on Fridays, on the amount of uh, muffins that were sold and wasted uh, on Fridays. So we would only um, the way we do that is by using the function called filter, and the filter function allows us to so we'd actually sorry, got a little ahead of myself. So let's only care about let's say we just wanted to isolate the day, like so t was like the first as like the amount of days since starting the observation, and then muffins sold and muffins wasted. So let's say we just want to focus on that data and get rid of everything else. So we use the function called select, and that's function allows us to limit the amount of columns that are in our data frame. So um, to do that, we'll use a select function, which comes from the tidyverse package. It comes from dplyr. So now, since I'm going to be working on the data, I'll do data restriction, which just means you're kind of like limiting the amount of data you have from one data frame or data table, and creating a new one that's going to be smaller. So I'll do cafe or just muffins. And then, so I'm making a new storage object, and I'm going to be using that select function. And to use select, it is a very easy, I mean, it has the same format as almost every function we're going to be talking about in this lesson and the next, which comes from the dplyr package. And the way it works is you start off by saying by using the storage object, by stating the either the data frame or the storage object that you have. So in this case, it's since we're going to be getting this data about muffins from the cafe object, we're going to start off by writing cafe. And now we have that, we need to state the we're gonna have to state the variables that we want to keep in, or like and the columns that we want to keep in. So we said we wanted to keep in t, which is the observation day, and then we're gonna do muffins. Sorry, muffins sold. Well, okay. This I just realized there's a small problem, and that's just the names of this of these variables. There are, I believe, spaces between them, and I don't think you'd have spaces when you're working with variables in R. So before we do that, we have to use another function called clean names, and that comes from the janitor package. So if we do library and then janitor, we can use that function. And to get that package, you just need to use the install packages and then do in parentheses, I mean in quotation marks, janitor. So now first we'll do Let's do clean cafe, and that will just be clean underscore names, and then we just put in the data frame or the data table that we want to clean. So just do that, clean cafe, clean names, cafe to make clean cafe. We'll run it. Now we could look at this, and when you look at the names, you could see that it's going to make it into a. It's going to make the column names into names that R can work with. And you can see I made a mistake here. It's a bread, sand, waste instead of breads and waste. But for the most part, it does a good job. So we only want muffin sold, muffin waste, and tea. So now back to what we're on. So muffins sold, muffins waste. Sure. Okay. So now we run this. And it says there's an error, and I guess it's because I must have misspelled something. Muffins sold, muffins waste. Oh. So I figured out that it was because I was using the old data set instead of clean cafe, I was using cafe. So always gotta make sure you're working on the right thing. Now I'll run this. And now we have muffins. And now you can see we only kept those three columns. But you can see here that there's some columns that don't have any data. So if you wanted, you don't have to do this. And if it's okay with the data you're working with, you can just remove it. And the way that you remove that missing data is you use the function, I believe you use the function, let me just double check. You move the function using you remove it using the function na omit, which just omits any row that has a missing value in any column. So let's just keep the same name. So we'll do na omit. And this is just a quick way to get rid of, there's other ways of doing it, but just for this example, we'll use na omit and just press run the code. And now that row has been removed from the data set. So I know this video is getting a little long, so I'll just go over one more function before wrapping it up and then continuing this in another video. The next function I want to go over is the filter function, and the filter function is a way for you to limit the data based on like the values you have in the rows, and it like with how select you're able to limit the amount of columns, and using filter you're able to limit the amount of rows that there are. So let's say you only wanted to look at the days, like you want to see how the cafe did on a specific day, let's say Friday. So you can do that by using the filter function, like I said. let's name it only Fridays, and you would use, so instead of select, you use filter, and filter has the same format and arguments as select. So you start off with the data that you want to use. So it's clean cafe, and then then you give R the criteria with which that you want it to keep or remove these rows. So for us, we only wanted, I said, we only wanted to include things from Friday. So you would do, so we would go to the variable, so the day of the week. So we want to do, we only want to keep rows where the day of week is equal to, and the way we like run this test, this logical test for R, when we say it's equal to, we just use the double equal sign, and then we're going to give it the value that we want it to be equal to, that we're saying to keep in this data set. So for I. So and then we're going to close the parentheses. So what this function's saying is we want to make a new object from the data set clean cafe that only has observations and rows where the day of the week is equal to Friday. And now we do this, we run it. Now we have a new data set called only Friday. And as you'll see, it only kept observations that had Friday as the day of the week. So there's multiple, if you want, there are multiple ways that you can filter a data set, and you can give the data set, like you can give filter, the function filter, multiple things that have to be true in order to keep it a value or a row in a data column. In a data set. And the way that you can add things is by using either the and sign, and then like another argument. So let's say I said only for let's go back to Clean Cafe. So only Friday and only days where you sold more than 5 muffins, let's say. So we do and muffins sold is greater than 5. So now you're only going to have observations where the day of the week is Friday, and they sold more than 5 muffins. So now we run this, and there's only one observation that was a Friday and had muffins sold more than 28. And you could compare it to when we just had this one. There were more observations. See, so it's a pretty powerful function, and if you don't want it to, if you want like R to use, like, if you don't want both of the arguments that you give this filter function to be true in order to keep it away, let's say you want to keep observations that are either the day of the week is equal to Friday, or the amount of muffins sold is greater than 5, instead of both having to be true in order to keep it, you would use this symbol, this like straight line symbol, which is like shift and forward slash or backslash. And that would mean if day of the week is equal to Friday or muffin sold is greater than 5, then it'll keep the function. So I think for now, for this video, that should be enough. The next video, I'll talk about the functions mutate and summarize to show you how to um, create new variables and also get some average level data about your data set. But for now, I think this was a lot, and it definitely gives you enough to maybe practice with. And yeah, this is the first lesson where we talked about coding, and I actually give you like code that you can try out. I'm gonna try to make these data sets available so that you can also work along. Um, but yeah, you can really do this with any type of data that you have access to. And there are many public available data sets that you can work on for practice. But yeah, thank you so much for watching this video, and I hope you enjoyed it, and I'll catch you on the next one.